Hi, and welcome to InterSystems Virtual Summit 2021. Over the past 5 years, InterSystems has significantly extended the breadth of its analytics offering. In the past, Caché and Ensemble included specialist OLAP Cube and natural language processing technologies for developers, fully embedded in the platform. With InterSystems IRIS today, you have a much broader set of capabilities that caters to a much broader audience as well. This enlarged audience now includes business analysts, data scientists, and other citizen users that are not necessarily part of the IT function, but can be part of the line of business and yet have to analyze the data of the lines of business. So for this audience that is not necessarily as technical as our traditional full stack developer audience, we needed to enrich our platform with quite a bit of user interface surface. So we've built a number of solutions and products that come with IRIS that cater to this audience in a more graphical way. In today's session, we'll not look at those graphics. We'll take a step back and we'll skip the graphics for a minute and consider a number of recent IRIS SQL enhancements that work well for analytics. Many of these enhancements are not there to compete with the GUIs, but on the contrary, are transparently leveraged by those products so that we can push the complex or the data-heavy calculations closer to the data, right into the database. The good thing about this is that they're available not just for the rich user interfaces, but also directly to the poor SQL developers like myself. We'll be going hardcore and look at raw SQL syntax right away, but let's make this a coherent story by giving ourselves a mission, or let's ask our boss for a mission. So here is our boss. Earlier this year, he already went out of his way to replace the punch card system with a proper ERP system that's deployed on an IRIS database server. So that probably means that he's not going to make any further investments in technology for the next few decades. So now he's asked me for reports, charts, and dashboards. And I have to find out how I can deliver that capability, how I can deliver that kind of analytics with just the relational database that we have. The specific question that he's been asking for is a sales leaderboard. How can I know which sales reps don't deserve their bonus? Which ones only brought in a small amount of revenue, or which ones gave too much discount to our customers? So he's looking for that kind of information visualized from the data we capture in our ERP system. So that's what we'll do. For this demo, we'll use the SQL Tools plugin for VS Code. I'm sure you're familiar with our very comprehensive and easy to use VS Code plugin for working with ObjectScript. SQL Tools itself is also another plugin for VS Code. We didn't develop it ourselves, but it's one of the most widely used plugins on VS Code for working with relational databases. So what we did is we contributed a nice driver to that project. We'll start from the AdventureWorks demo database. This is an open source database that was originally proposed and contributed by Microsoft, but it has seen quite a bit of adoption in the broader database analytics communities. We'll be posting scripts to load this data set and also of all the demo queries. So this is how SQL Tools looks like, and we've connected to our local database, and we can see all of the tables in the AdventureWorks schema, and I can just browse through them if I want to. So as you can see, this is a fairly straightforward schema. It is actually already in somewhat of an analytics-friendly format. That's just the flavor of the schema we took, but it's a very convenient one to work with. Okay, back to our assignment, because time is money. So the question we were asked is, how can we show a leaderboard that shows for every employee, for every sales rep, the sales they brought in and the discount they gave, and maybe also the percentage discount, if that is as a relative piece of information interesting to see. So I can run this simple query. Don't worry too much if it's too small to read. Again, we'll be posting these later on if you're interested. And if you have any questions, feel free to use the sidebar Q&A facility. So here we can see our employees. We see our top sales guy who brought in the most revenue. And here we can see how much discount they gave. This is pretty hard to read. So we've sorted by our second column. So we've sorted by total revenue they brought in. But it's very hard to parse out, is the discount that they gave relative to the sales that they brought in, is that significant? Is that too much? Is that too little? And this doesn't say everything either. What you could do is, if you could try and visualize that with bar charts, and that can give you a better idea or a visual cue of how these numbers relate to one another. But that only works if you have 6, 10, maybe a dozen different employees for which you would need to visualize these bars. As soon as you have a large sales organization, in this case, that becomes quite problematic, and that becomes very hard to comprehend visually. So what we would like to see is not just the absolute or relative numbers of the amount, but we would also like to see how well they did relative to one another. So we want to see the rank. So what we're doing here in this next query is we're creating the rank, and we're creating the rank over a certain window. We're using window functions. So in this case, we're taking the rank over the entire query result, and we're going to take the rank ordered by total sales. And in this case, we're going to take the rank ordered by total discount, and in this case, ordered by average discount. So now, in this case, we'll be seeing a couple of simple integer columns that will give us an idea what the rank is relative to the rest of the sales audience. So here, for our total sales amount, of course, it's a nicely incrementing number because we're still sorting that way. But now here for discount, I can see that indeed my top sales guy is actually also the one that's giving most discount. I can see that the second best sales guy, he only had a small, let's say less than 3% fewer sales, but he had significantly fewer discounts, as you can also see from this chart. And as you can certainly see if you look at the rank in the discount percent column. So those window functions help us in calculating aggregates across a certain window. We can also make it more refined and bring in the fiscal year. So we can calculate these ranks not just looking at the overall window, but looking at a smaller window as well. So that's similar to the group by that you would use for the whole query, but now specifically for calculating these aggregates. And now, for example, in this overview, you can see that this was our top sales guy. If you look at how he started off, so he was already a pretty good sales guy when he joined in 2010, or when we first started tracking the numbers. And in that first year, even though he was third in sales, he just didn't give any discount at all. So this was truly a star sales guy in his first year, but then started giving out a little more discount later on. So maybe this is somebody that our boss would like to speak to. Okay, so far so good. Window functions help you create aggregates based on a sliding window or groups of rows within the result set. The main goal of window functions, because all of the things that you've seen are things that you could obviously do in post-processing. If you take the initial result, the initial simple group by aggregates, and you pull it into an Excel file or in some reporting solution, you can probably add an additional column that does some of that. You can write your own formulas, but that's all post-processing. That's computationally possibly expensive, and it requires a separate technology where you're going to do those computations. So pushing that all into your query is very valuable from a technology investment point of view, but most importantly, as the data set grows big, also from a cost efficiency or from a computational efficiency point of view, because you are doing those computations as close to the data as possible. A couple of other examples: contrast row data with summary. So for example, if we would have groups of sales guys, we could look at the average percentage or the averages per sales group in a single row. We could compare with the previous or next row. We could calculate running totals. Those are all examples of things you can do with window functions. Okay, so far so good. Let's look at our leaderboard again. So we have our query that delivers the refined numbers by person, so by sales rep, by fiscal year, with the ranks calculated per fiscal year per sales. Not all sales are equal. So our sales sell internationally, so they also have to deal with different currencies. So therefore, there is the currency volatility that may have an impact on their ability to sell at a low discount. So our boss would like us to take that number into account. And he's obtained this nice, simple CSV file that has, for every currency, also has a number that expresses the volatility of that currency, and would like us to load this into the database. So we've already created a little table for that, and now we'll load this using the new load data command. So this command really couldn't get much easier than that. We can load data from files, CSVs are supported, but you can also load from a JDBC source, and you specify the target table. This command can be refined with columns and values clauses as you see fit. And now we've got our volatility information nicely available in a SQL table. So from CSV to table in just a single quick command. So what does that mean here? Again, I mentioned that this is a very easy to load, very easy to use tool that supports both CSV and JDBC sources, and we'll be adding more capabilities to it in future versions. This is new in 21.2. And to refine the command, you can use the columns and values clauses. The values clause is exactly the same thing that you're familiar with insert into commands. And then there is an additional using clause that you can use that you might be familiar with from integrated ML, where you can override the default behavior, so specify specific parameters. In this case, I could specify whether there's a header column or not, or override the default field separator. So the data is in IRIS, and now I need to incorporate it into my formula. So I could just use it as a multiplier, but that would be a little too easy. So I could just multiply the volatility of the currency with the sales amount and just take that as a sum. But my boss wants to apply a somewhat more magic formula, and he believes that the volatility sort of plateaus off after a while. So somewhere in our sum, we need to kind of drop off and forget about the volatility and just count the numbers as they were. So how does that work? How can we achieve that? InterSystems IRIS has already supported user-defined functions that operate on a single row at a time for a long while. So you could give them any number of input fields and to come up with a scalar output field. We're adding user-defined aggregate functions to that in 21.1. So how that works is you can first define your user-defined functions, and you need at least an iterate function that will iterate over all of the rows in the window that you're aggregating, in the group that you're aggregating, and then optionally add a user-defined function to initialize or a user-defined function to finalize the result. In our example, we're just doing this sort of a weighted sum. So we have our temp variable, and we have our amount that comes in and a volatility that comes in. So these are the columns that are selected per row, and we return our sort of plateau result. So defining the, let's first define the function, and then we can define the aggregate function. So the aggregate in our case has two input fields, whereas a sum or a count or a min or a max usually only takes a single one, and we specify that works with the iterate function that we just created. And now we can use this in queries, and here you can see that we're using the AdventureWorks magic form aggregate function that we just defined along with the sum, and you can see how it adds a certain multiplier to the sales, except for US dollar, because in that case the volatility is just 1. So if we now want to incorporate this into our overall query, so now rather than taking the rank over the full sales, we're taking the adjusted sales based on our magic formula. So this query is starting to get a little long, but still it gives us the results that we were looking for, and now taking into account currency volatility. Okay, user-defined aggregate functions is just another way for you to plug in custom code, to plug in application-specific computations. And now, thanks to embedded Python, which you'll hear more about in other sessions at this conference, you'll be able to not just express those in object script code like I did, but also in Python code if you're interested in that. So we saw this query as getting quite long. So what we might also do, if we're still not done, say our boss has like 5 additional requests pending, but we want to materialize these results, we want to save a copy on the side, what we can do now is create a table based on a select statement. So taking our big long select statement, and that will do exactly that. That will save a copy on the side. And now if we would go back and look at our schema, we'll see that it has a new table with this name, and that has all of the rows that are in there based on the select statement. So if I go here and refresh, I'll see that I have my new table with the columns that represent the columns going back from the query, and I can open it and see the exact same results that I was looking at earlier. And now I can use this as a base. So that's somewhat similar to defining a view, but now also physically saving the data on the side, which may be desirable in cases where you have a lot of repetitive computations. We call this CTAS, so create table as select. And examples where it's useful is, for example, in long ETL scripts, if you're wrangling your data, getting it ready for machine learning or other data science applications. This is a very simple yet useful, convenient extension. So thus far, we've seen 4 examples of recent IRIS SQL extensions that help us make sense of raw data and lay it out in a way that's easier to understand. In other words, we've used SQL for analytics, but it doesn't stop there. You may be familiar with Integrated ML, which we launched last year at Virtual Summit 2020. And I can already expect my boss to ask for the next thing. So he would like to get a model that predicts the most likely or the most appropriate discount for the next opportunity, for the next sales opportunity. And maybe he wants to trade it on his top sales segment and then use those predictions, compare those to what his newer sales contributed. So that would be a really good use case for Integrated ML, because Integrated ML is a full SQL feature. So you don't need anything other than SQL to use it. So it's available in our relational database, and we don't need to get out of our comfort zone and start using other tools. So just to show you the typical commands for Integrated ML, with create model, you sort of define where you're going to find your feature information and which field you want to predict. Train model is for doing the actual kicking off the actual machine learning, and then predict is going to be the simple yet terribly useful function, scalar function that you can embed in all of your queries anywhere in the select clause, the where clause, or any other part of the query. Okay, so we've looked at some of those recent additions, recent extensions. Just to sum up what we've looked at the window functions, so the over class, partition by, order by, to define a particular window that you should aggregate over. We've looked at aggregate user-defined functions, user-defined aggregate functions, I should say. We've looked at create table as select as another new syntax utility. And then new tools, load data, a very useful command, very simple, very easy to use, yet very powerful, and also leveraging some optimizations under the hood. And then the familiar Integrated ML commands for creating and training models. So with all of these, again, we're trying to push computations closer to the data. We've seen how customers are taking advantage of these in their scripts, in their application code, sometimes in their query tools, and they might be combining it with version control to have something really powerful, fully SQL script driven. That's all available within the basic, the most basic IRIS licenses, including the community edition. But there's a chance that your boss isn't as much as a Scrooge as mine. So, and that they would be interested in taking advantage of some of these other SQL capabilities that offer a nice user interface, something that's a little less hardcore than the command line or the raw SQL that we've been working with thus far. So in a nutshell, If you're looking at a data wrangling use case, if you need to modify your data and would like to have a canvas to do so, so very fit for citizen users, very fit for non-technical users, Alteryx offers that kind of functionality. Last year, we announced our partnership with Alteryx, presented a session at Virtual Summit 2020. Feel free to give it a try. There's a lot of components in there that still allow you to choose whether to push the computation into a database, if there's any, or to do the computation on the Alteryx client side. So that still gives you a fair bit of choice. Then, if you remember that long query that we built throughout the demo, that query is useful. And if our boss wants to use it for his leaderboard, that's great. But if there's a sales team leader that wants a slight variation or that only wants a subsection of it, so there's great value in being able to have a single business model that defines business metrics. So our adjusted amount and the dimensions, the fiscal year, the definition, when does the fiscal year start and end? So without any ambiguity or question marks for anyone accessing it. So being able to model your business metrics and dimensions in one place and then have all BI client tools, so including Tableau, including Power BI, Click, or plain SQL clients, being able to wire them to that single model, that is something that IRIS Adaptive Analytics offers with a very nice user experience. And it also does some interesting tricks to offer higher scalability by automatically and autonomously building and maintaining interim result sets and pre-aggregated results to speed up future queries. And then the third solution that is also based on top of the SQL that we were looking at earlier is InterSystems Reports. InterSystems Reports is an environment that allows you to develop reports, highly customizable reports, also in a visual way, and then schedule them for distribution in PDF, XLS, HTML, or any other format that you like. That concludes our session. I hope you enjoyed the whirlwind tour through some of those recent SQL enhancements. If you happen to have any questions, feel free to use the sidebar option next to the screen or to submit them for our live Q&A session on Friday at this conference. Thank you for watching.